Okay, welcome. It's a Saturday. I'm going to do all ESP32 stuff. I figured, I think, most of it out. The quirks, everything. So we are going to do a bunch of it. Now, if you're not aware, there are different generations of ESP32 stuff from Expressa. So let's bring you out into the view here. Oops. There we go. Well, we have to zoom out because we cannot have all four in here. Let's zoom out a bit. Okay. Okay. So most of the ESP32 stuff, even stuff like the feather, which is an S2, this guy here, are all based on about 4 generations of stuff from them. So this one here is the ESP8266 stuff. Okay, still developed for, still valid. This guy here is the ESP32, right, without any S's after it. So this is like, if anything, it would be like ESP32-S0 or S1, right? This guy here is ESP32-S2, and this is the latest breed, ESP32-S3. Now, some things have changed. This guy here is an Adafruit product. It's a feather. And one of the things we have support for in this one, possibly this one, well, definitely in the chip, but not maybe this board, and definitely in the chip, but not in this board, is Arduino, and Python support, CircuitPython. So definitely our little feather, you could put any of the environments on. Okay. And what we have here also on this particular feather is battery. There's a charging circuit on it. And this guy is a STEMMA QT port. Okay. Little tiny guy. Yeah, I2C. Okay. Now all these guys all generally come with 2 buttons on them. So 2 here, 2 here, 2 here. Okay. So one button is the reset button, and one button is what they call the boot button. So sometimes I'll say reset flash, like on this one. This one says reset boot. This one here says reset boot. And this one here says boot reset. Okay. And when you press those buttons in certain order, you cause these things to do certain things. So, for example, if you wanted to get into programming mode on one of these, you could hold down, for example, the boot button, like here, like so. Then the reset. Hold it for a little bit. Let go of the reset. Hit go, and this will change its way. So same with this one, and this one. Okay. Now these guys have the old micro USB 2.0s. But this guy here is new product. It has USB-C, which is really nice. Even this newest product still micro USB 2.0. I'm surprised that these guys didn't put in USB-C ports into the board. But you can see that the USB-C port uses a little more space than the USB 2.0 micro ports do. They generally have some sort of LEDing on it. This one here, it's right here in the corner of the thing, right there. This one here, they bury the LED right here. This one here, it has an LED on. I think it has 2 LEDs on it. Yeah, right beside the ports. One here and one here. And then this one here, we have an LED here for power indicator that you have it on, but the primary one for indicating stuff is the NeoPixel that's sitting right there. Okay. Now, as you know, I have a whole batch of these different ones here. But I do have a bunch of different ones from Arduino. Sorry, not Arduino. Mr. Adafruit. So feathers. One I don't have from them yet. They were out of stock. Was the QT ESP32. Yeah, very tiny one. And sometimes when you work on these, you don't actually see this silver. You see a different way of doing it. But 90% of them are all this silver thing. Okay? Now, when you're programming for these things, and let us go to the desktop here. No, that's not the desktop. Let's try that one. Okay, so I've been using Visual Studio Code. Now, when you install Visual Studio Code and then you install PlatformIO, one of the parts of PlatformIO is various platforms you can pick. Okay, so when you bring up the house like this and we go to, I'm just going to scroll this down a little bit. So we have boards, platforms. Okay, we have the Atmel platform, AVR, the Mega AVR, the SAM platform, the Express 32, the 8266, the RP2040, the STM32. When you deal with these two platforms right here, what you're really doing with PlatformIO is adding in a subset of ESP-IDF. Okay, to handle that. But do not bother trying to do this guy here, because the ESP-IDF that's installed in here is a bit dated. So the problem is that in order to do this board, you have to have ESP-IDF 4.4. And you can see here in this one, it's 3.4. Okay, and this one's 3.2, for example. I think they talked about this in the end of 2021 PlatformIO, that it had updated to 3.4.2 or something like that. I can't remember. Or 4.3.2 or something like that. But the problem is you actually need a piece that's not actually available as the preferred release. Okay, so you're going to have to be careful of that. But if you want to do any of this, no problem. So what we're going to do first here is we're going to program the 8266. And I'm going to get out of this guy here. We'll come back to it in a bit. So we come up now. When we got out of that project, the interesting thing about the other programming environment alternate to PlatformIO called ESP-IDF is that it has its own set of toolbar at the bottom and everything. You notice that this thing shrunk and just disappeared. We still have our house, which is the PlatformIO home. Okay, so we can go and say new project. Okay, we'll give our project name here. What shall we call it? Blink and dash ESP8266. Okay, so we're going to select the board. Express 32. Okay. Actually, not the Express 32, but we're going to scroll down a little bit into here. And we're going to find if they have it in the list. There, Express 8266. Okay. So now you see these ones. There's the Who's Out. This is not this board. I have it over in the bin. I have one of these. What we really want here is if you look at the chip on this, it'll say, not this one, this one here, it will say ESP32-E. Okay. I believe you can just use the ESP-MX dev kit. to do this one. And we can check on the PlatformIO site which one we're going to do. They'll actually tell us which board. So I'm going to just come back to that in a sec. We'll find a more correct board. So, wrong browser. Let's go to the right browser here. So we can actually look this up. PlatformIO ESP-12E. Kind of like so. And you can go to the documentation. And what we get here, you get this sort of information right here about it. Okay. So we're going to, as far as a board concerned, as I said, we just find one that's, because we can modify the PlatformIO file anyway. There. Generic, blah, blah, blah. Right? 12E, right there, exactly what we want. So we'll take that. Now we can choose platforms here. Arduino, Simba, R2S, non-R2S. Okay? In this case, the easiest way to work with this board is actually to do PlatformIO. To do Arduino. So we're going to stick with Arduino on this board. Okay? We're not going to use default locations. I actually want to place my project somewhere. So we go project. And actually, I have ESP32 here. I think I'm going to break this down. I'm going to go and say a new one. And we're going to call this ESP8266. Okay? And then we're going to go new, and we're going to create this. I think it wants to create a folder based off of your project. I'm going to just test that out, actually. No, we're not opening a project. New project, please. So, project ESP. So I think it will create a project name based off the title there. So let's just say finish in here. Okay. And go back to the desktop. No, not that one, not that one. This one? Yeah. So it created all the stuff for us. You can see down the side here. And we have the correct stuff in here. Okay. We can go to source. And we have main CPP. And you got your classical Arduino. Yes, by the way, I've mentioned this before, but when Arduino IDE environment is used, the actual one, and they call it .ino, in reality it's a CPP file. It's just that Arduino's IDE does some wrapper work around it to make it a little less obvious. So now we need a Blink program. Now I wonder if I have got one available here already. Code, platform, Blink. Yeah, I do have a Blink one. So Control A, Control C. I'll get it out of my editor. You're not seeing it, but I'm just doing that. And I come over here, and off the bottom one, I'll just go Control V here. And we don't really need the extra piece here. So Blink. Okay. Now it says LED built-in here. Okay. Just let me just check the text. I did miss a line here. Now by default, this is assuming a that this LED, for example, mapped on here is the built-in. Okay. Okay. Now I'm going to just add to this desktop here. there, the extra cam, so you can actually see, so I don't have to flip back and forth on the scenes. Okay. We're going to try it out, see what happens. We might have to modify this where the LED thing, we have to define the blink. And we can go rooting around and find an actual, I actually have probably a blink program just for ESP. But we will see if we can actually compile it and then push it to the thing. Okay, so first we need to plug it in. Now this guy here only has one port. Okay. And I'd be messing with it because it is blinking. Okay. So we want to test out that our environment is actually working. So we'll hit the check mark at the bottom just to compile. No problem. We built. Okay. Now we can go here and say PlatformIO new terminal. Then we're actually in a platform CLI, not a bash CLI. Be careful of this. In any of these development environments, there'll actually be two consoles. Right? If you go up here to the top and say terminal, new terminal, you're going to end up with a bash terminal. If you go down here, on the other hand, you click PlatformIO, new terminal, you get a PlatformIO. That means the environment in this terminal is specifically targeted to this PlatformIO and this particular project. So we're going to see if we can push this to the thing. So we're going to upload. Now one of the things you have to do, if you get this connection thing down here, is hold down the button. The flash button or the boot button. Okay, so we see here it's not working properly. Okay. The problem is probably we don't have the right port. So if we go to PlatformIO here, we don't see this. Well, there's two parameters we can add to this. First of all, upload speed equals 916,200, I think it is. I keep having to do the calculation. I should write this down actually somewhere. 115,200 times 2 times 2 again. 6,800 times 2 again. 921,600. Sorry. 921,600. Okay. That speeds up the upload. And then the other one, of course, is upload underscore port equals dev and then something. Okay. So I plugged it in. Dmessage. And it thinks it is USB 0. So we'll go here and we'll add in TTY USB 0 and save it. Let's see if we can push again. Since we change, I find when you change the INI file, there we go, writing right away. See? Goink. And this blink worked. So you can see the blink is actually slowed down. And to prove it, let's go to our blink program. And we'll change this. We'll make this 5,000 instead of 1,000. Okay? And we'll upload. It's got a big long delay now on the off side, then the on, big long delay. So yeah, blink is working. So as you can see in this device, whoops, that's another thing in PlatformIO. Until you actually click in this window and then hit the space bar, it'll just repeat the task again, over and over and over again. So LED built-in works just fine. There we go. We just did the ESP programming for an 8266. Straightforward Arduino. No problem. And this happens to be a Lowland Node MCU version 3. Okay. And this also happens to be a generic Chinese off AliExpress for a couple of bucks. So it's a very cheap controller to get, and it works just fine. Okay. So let us save a workspace for this so that we can come back to this later again. So I will save a workspace, and not in the source tree. I will save here. We're going to call it ESP8266 Blink. Okay, save it. Okay. And we don't need two PIO homes. Okay, voila. Okay, this is just complaining about something weird. Who cares? Okay, so we're going to close this project off because we dealt with that controller. Close workspace. There we go. Okay, so that's this one. Now we move up to one, and this is the ESP32. And we'll plug it in. Now I need to check the directory where I have the ESP32 for a sec. So we go off to the work directory, and we go off to PlatformIO, projects, and I'm interested in the ESP32. So this guy here is an ESP Room 32, i.e. this one right here. But we're going to redo this one. Okay, so I'm going to delete, doink, okay, just like that. And this doesn't work because this we'll have to deal with this in a different way. We can get rid of it. Okay, so we go back to our little house in PlatformIO, and we say new project. In this case, we're calling it ESP32. No, we'll call it ESP Room 32 dash Blink. We'll select a board. There we go. Now, I don't like that board actually, because I know on this one you can actually get away with ESP32 dev, something like that. We just have to find it here. It should be this one. So especially have ESP32 dev module. This is like a generic one that'll handle all these guys here. And again, we can actually, on this one, we can do Arduino or the IDF frameworks. We're going to do Arduino again. It's easiest. Now location, no. So we go projects, ESP32, finish. Okay. I'm going to open up a terminal of PlatformIO down here. Now, just like the last one, we're going to go upload underscore speed equals 921,600 to speed it up. We're going to go upload underscore port, and we are going to check to see what port we actually have by going dmessage. Again, USB 0. It's supposed to auto detect, but I find the auto detection kind of flaky. It doesn't always find what you, especially when I have more than one device on, I can't figure it out. I have the macro pad, and it's also a port. So, Control S. Okay, so that's that. We go to our source here, main CPP. We'll just get rid of this chunk here. We don't need it. And we'll go back to our text editor and grab the blink again. Control A, Control C, Control V. Okay? Control S. Okay. Now this is a problem. So the identifier is wrong. So in the older one, the code actually has that. In the newer one, it doesn't work. Okay, so what we have to do in here, you can see the problem, built-in undefined. Okay, so what we're going to do is find the alternate blink program. So we go ESP32. Here, I'll show you what I'm just hunting for. Let's turn on that one. Is there room blink LED? So basically, if you look at this, this is very similar board. Okay, it is an ESP32 room, blah blah blah. So we just need the code section from this. Da, 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 da. I think this is what I did before. I just borrowed it from here. Yeah, right here. Control C. And what we do here in this one. Okay, we'll clean up our code a little bit. It's kind of not very pretty. I am not a fan in C of typing our thing like this. I prefer doing this. There are many format wars over this. So there we go. Okay. Now, the trick on this one, is it pin 2 or is it pin 1? We don't know. Not yet. I think it was pin 2. Pretty sure. We'll come back here. Nope. This one. So we need to know what the pin is here. Okay. So we control save. Let's compile. Let's see if we compile properly. No problem. Now we'll do a push and see what happens. Now, as I said, sometimes when you push, be prepared to put your finger on the boot button. Like that. Okay. And I look at the thing and I don't see my light blinking. Okay. So it's not 2. Let's try pin 1. Could be pin 6 too. Control S. And we will and there we go. Blink, blink, blink. So yeah, you'll find that some of these third-party boards, the LED will be on one pin. It'll be sharing a particular pin. Another one will be sharing another pin, yada yada. So, but there you go. We blinked this ESP32 with our classic little blink program. Now, I like my setup so much, I will make a workspace for it. So we'll save workspace as ESP room 32 blink. Like so. And we will put it in here. There we go. We got an extra home. We don't need that. So there we go. Now remember, click into here before you hit the space bar, otherwise I was just redoing everything. Okay. So that's board number 2. Okay. So I'm going to close this project. Like so. Pull it off. Now we come to one of the S2 ones. So this is the feather. I'm more interested actually in programming a non-feather. So I'm just going to go to my collection of ESP stuff. See if I can find in here a board that's not a problem is I think all my S2s are I think they're all in Python mode. And they're not in So we have these guys. These are Metros that are actually ESP32s. You know, I have more of these, and I don't know where I put them. These two guys here are same idea, but you don't see that silver shell on them. These are Swan R5s, I believe. Where did I put all those boards? Did I stick them in the Arduino factory here? Yeah, just a sec. We need to dip into our supply down here. So I will just put this back on the shelf. And I should have pulled these out earlier, but... Arduinos, hats, Arduinos Unos. I think these are all Unos. Is there any ESPs in here? Yeah, I think these are all Unos. And way down here, Megas. I was sure I had some other S2s. I will have to go routing around, I think. This can go there. This can go here. And this can go here. And this can go here. And these guys can go here. Well, anyway, can't find them. Not a biggie. But I think, have some regular no-name S2s. So we'll borrow this one here, and we'll plug it in. I'll need the USB-C cable because it's a USB-C. But I'm pretty sure this is in CircuitPython mode. Yeah, I was right. So this is in CircuitPython mode. So we go here and we click on, I think, on the lower one. There actually might be nothing on here. Not even a workspace file yet. And once we have that, we can go here and we say File, Open Folder. CircuitPy, say OK. Yes, we do have a Blink program on here. The trip. Do we have a NeoPixel in here buried somewhere? Can't remember. No, it doesn't look like it. So I think this is the wrong code for this. Or I'm the wrong one. No, I am on the right one. So our code is wrong here for this. What we want here is a CircuitPython regular Blink. It's not a NeoPixel here. Let's just see if we can find this feather ESP32-S2 and find a Blink program for it. So ESP32-S2 feather Blink. Here we go. What do we got here? Blinking the LED. Okay, so we need this code in here. Control A, Control V, Control S. There we go. So we changed the code around a little bit. Now, see this guy right here and this guy right here? It's because VS Code here, settings, is incorrect. So what we want to do here is, it's empty. It's not supposed to be empty. So we're going to close this off. We're just going to close the folder off for a sec. And coming in on Explorer on this. And we're going to reset that. So by just deleting the VS Code directory in CircuitPy. So the next time we come in, it gets recreated properly. So I come back in. I do a file open, folder, CircuitPy. There's nothing here. Bundle is included. So VS Code is included. Settings is actually properly populated, like the way it's supposed to be. And we look at Mr. Code here, and now this happens. Everything's correct. Okay. And our LED is blinking. You can see it just faintly there. It's a very tiny LED, blinking red. Okay. So on their page here, you actually can go to here. This is CircuitPython mode, but you can go the Arduino blink, for example, on this thing. And you'll get the blink version of the blink. Now they have it with the Arduino IDE, but I can do it in here. I could go to PlatformIO, for example, and find the board, pick the Arduino framework, and use this code right here, and it will work. I don't actually have to use the Arduino IDE. I do have both versions, the 1.8 whatever, and I do have the new near final release of the 2.0. Was it RC2 or something like that at the moment? So yes, I can go to those environments and do it. Same with the CircuitPython. You can actually set it up in the Arduino IDE also. But you get the idea. Now, this particular version, see that little chip right here where my cursor is on? Yee. This is the version of the board without it, and I have the version of the board with it. They're identical boards, except one has a BMO 280 or whatever on it, and the other one doesn't. She thought it was just fun to throw on an extra sensor onto the board. Ooh, okay. Fine. I also have here, let me just see if I can get it out. Remember, I also bought this guy here, the Adafruit ESP. Oh, this is an unused one. So, ta-da. Okay. We do have an S2 that we can mess with here. Okay. This is an ESP32-S2 Feather. I think it probably just has the basic testing program on it at the moment. So, unlike the other programming where you just pull the connector off and whatever, because it doesn't actually have a floating drive on it, this does. So I am going to make sure that I actually correctly, first of all, save the workspace in here, and we will call it this is a Feather, right? Yeah. So we'll call this a Feather ESP32-S2. And that's what it is, basically. Yeah. And we'll save it here so that we have a workspace file stored on the drive here. Yep. And then we will go and say File, Close Workspace. And we'll go to File Explorer here. And we will safely remove our drive. Safely remove. Like so. So that one's that one. Now let us put on one of these new. But in fact, first, I'm just going to turn the soldering pencil. I want to put the legs on. Right? Hey, we all need legs. So. So. We need some pins. I don't think I need all those pins because this is a Feather and they always give you 2 extra pins. Nope, this one's okay. Sometimes they do. No, I'm going to do it from that side. Okay, so we have pins here. So this one, and we don't need all these. So we need our needle nose here for a sec, and 4. So we have to chop 4 off the end. 2, 4, like so. And we should be able to put it in there like so. And then they don't recommend putting a stacking header on this one because of the screen. So I wouldn't do that if I were you. No, we're 2, 1, 2 in. Okay, gotta move out. There we go. Let's try this again. There we go. So how's our melt? Good old soldering pencil. So get the clock off the cable because it's getting in the way, and move the 0 to the side. And the needle nose. And put some goggles on so I can actually see what I'm doing. Okay, so let us solder a little bit here. Now this little peel thing here protects the screen a little bit so we don't abuse it. I'm curious. I think I should see the code spinning by on the display. Can't remember what exactly happens with this. I haven't done too many of these boards with the built-in display like this. Almost done. One more to go. There we go. Okay, take the clips off. Okay, so we built ourselves one of the new ESPs here. This one here. And we plug it in. Oh, cute. It has all these things. ESP, feather, battery, I2C, 0xB. Okay, so what we want to do is put it into UF2 mode, if I remember correctly. I think you could put Arduino on it. I just need to go to their webpage for this. Let's go to the top here and find 5300. Not in the learn in the shop, please. This one right here. So we are going down to technical details. We should be able to push some code to this. Let's see what we can do. Okay. Right now it's got something in it. So we're going to just change this to the blink LED. So, okay, let's begin and say file. No, we need the house, PlatformIO, right? New project. And we will call this ESP32-S2 blink feather TFT, like that. So we need to find I don't think this feather has is in here yet. Oh, we can do this. This should work. Right? ESP32-S2 feather development board. That should be fine. Okay, so projects, ESP32, finish. Okay. And we just have to wait for this to complete. Okay, so we are going to add in our upload speed equals 921,600. Sure, why not? Okay, whatever. Upload underscore port equals, and we need to know what port we ended up with on the side the message. This time it's ACM. So we have an ACM 1. Probably because the macro pad is ACM 0. So dev tty ACM 1. Okay, I want a terminal. Okay. Now notice all the extra icons. These icons more toward this side are the ESP-IDF, and these icons more to this side are all PlatformIO. So what we're going to do first is go to source and make. Okay, so we need a blink program for this one. That is, I'm using the wrong one here. I want to use I think the framework is wrong. I think I created this wrong. Just a sec. Actually, let's just start over. I'm pretty sure I created all this wrong. File, close, folder, don't save. And let's go to our work here, and we're just going to wipe it out and start again. I wasn't paying attention to framework. I wanted Arduino on there. So platform, projects, ESP32, U. First of all, rename, and I'll take the name, and then I'll delete the folder. Okay. So let's try again. House, new project, Control V, feather, okay, but we don't want that. Oh, we don't have Arduino for it. Oh, okay. Okay. We're not going to create this in PlatformIO. Okay. We need to switch tracks here now and use the other one. So what you have to do in here is you have to say open folder. This is the ESP-IDF framework and development environment this time. So we are going to, so unless I CircuitPython this drive by putting the UF2 file on, actually I could check if yeah, it does say CircuitPython Arduino. I think I don't have the right firmware on it, so it's not showing up correctly. Yes, where is... So they're missing a page. They're actually missing the page for this. So, how do you do this again? We need what we need out of here is feather ESP32 and S2 TFT UF2. There. This is the page we need here. So we have CircuitPython right there. Okay. And so should we put CircuitPython on here or should we put Arduino? Well, I was planning to turn it into CircuitPython anyway. Or what do you want to do? Arduino on there. Or I can try this. Okay, let's go back to our original plan here. Choices, choices, choices. Since we're dealing with ESP-IDF, let's make an ESP-IDF. So I've installed an extension in here called ESP-IDF. Just a sec, let me close this. ESP. This. So this environment deals with practically but it does it from ESP-IDF's programming point of view. Now, when you install this plugin, one of the first things you have to do with this is configure it. Okay. So you do all these prerequisites to install it. Make sure you have certain packages available. Okay. And then you need to configure the extension right here. Now, when you configure the extension, by default, it will install the latest release version of Express IDF from them. Now, what do I see Express all the time? ESP Resif. Wow, that doesn't make anything. Well, anyway, it installs 4.3.2 or 4.2.1, something like that. But it's one back, and if you do that one, what happens is, see how it says S3 in here? It's capable of doing S3 in here, but what will happen is it won't work because you have a version of the IDF that is one back from it. Do I have the page still up? Let's see. I'm just checking something here. It's in the other browser. Yeah, if you go to their GitHub for this, you'll see that they have, and if you dig a little bit, you'll find the 4.4 version. Now, when you run this setup, sorry, I didn't mean to pick help on Google. Go away. If you pick 4 and you say configure the extension like this, you pick advanced so that you can change this to release 4.4 branch, not the default release 4.3.2. Okay. Now I've already done all this. Set this all up. You can also do this as a zip file. That's all that really does. GitHub's fine. So once it's all set up, what you want to do is you need to open a folder up at your destination. So in our case, we need Mr. Work again, work. And we need, in this case, I made a tree for just for IDF projects. Okay. And I already have the Blink program here, so I'm going to use it as an existing one. Okay. Okay. This system uses CMake and a bunch of other stuff, and it's kind of tedious, but I've caught a couple of problems in it. One of them down here, this part right here at the bottom where you specify the port, it's supposed to set an environment variable to determine which port this is sitting on. So if we go to dmessage, for example, on this one, it says ACM. Right now the Blink program thinks it's on T2I USB 0. So if you go like this, and are we on ACM 1? Yes, we are. So we go ACM 1 and we set the environment variable. So supposedly it's updated the IDF. And let's try it, but I'm pretty sure it's going to have a boo-boo. Okay. Now in here, I found that this file was overriding this file. So we have ACM1 in here, but as soon as you made the workspace version, this was mostly empty. It threw it for a loop and started doing the wrong thing. So I'm going to fix it in here also, ACM1. Okay. Now we don't need these files anymore. Go away, go away, go away. So let's build. Now we're concentrating on the left side of the tree now. So the trash can just is like a make clean. So we want to build the project. So it's going to build. Okay. Oh, one thing we have to check. I forgot all about it. We're not an ESP32-S3. We need to change this. We are an ESP32-S2. Okay. And then we need to rebuild again. Okay, so we built, remember, click, then spacebar. Okay, so let's try to write our stuff out to the device. Okay, it didn't like something, so we have to have a look. Oh, and I wish these dialog boxes here would just disappear right away, but they don't. I got to find that out in Studio why not doing that. Now this could be a symptom of Which one did they call out? ACM1. Yeah, okay. Let's just unplug this and just double check D message. I wonder if I'm on ACM0. Okay. Plug it back in again. No, we are on 1. So we can't connect to it for some reason. Okay, now this is a case where we might have to do the dual button thing here. So let me just make sure I got the right one. Boot, reset, let go, let go. And are we in programming mode? Yes, I think we are. We are now in programming mode. Let's try to see if we can push again. Yep, there we go. Okay, so what we have to hit now is the reset once. Okay, there is actually a whole setup thing for this. Let me just bring it up here. So what we have here is we serial flash config before flashing, after flashing, stay in bootloader. I think that's what you have to do. And then we can close that and here and go and try. Whoops. Let's do this again. Out. In. So we are going to hold down the boot button, then the reset button, then let go of the reset button, then let go of the boot button. So we should, yeah, okay. Okay, so now we try again. Okay. And we just check here, bootloader. I did say no reset. I say stay in bootloader mode. Okay, let's find out what happens when we unplug and just plug it back in. Nope, we're not doing it right. So I'm missing something on this board. I changed this. Let's build again, because I'm damn sure I changed this, the parameters. This environment is a bit different than the PlatformIO environment. It's a bit pickier about certain things you have to do. Okay, so that. Okay, so we should be back in that mode. So definitely flashing. Okay, flash is done. So you hit the reset key. So let's just unplug it. Well, we obviously aren't blinking the right LED here, so their Blink program is quite different from. I should see if I can. I have two of these. I should turn one into Arduino and one into CircuitPython. So what you can do here is we go back to the CircuitPython page for this. Okay, and the download. Okay. So there's a whole set of instructions here. So what you want to do is you plug the board in, hold down the boot, then hit the reset and blah blah blah. Alright, we need to download the zip file of this. So there's a bin and a UF2, and we need actually we need to convert this. Let's see if I can do a conversion job on this, if I can remember how to do it again. Yeah, okay, so you download the bootloader zip, and we go to controllers. Do I have the feather in here? No, I don't, not yet. So we'll add feather ESP32-S2 TFT. Okay, we save that in there. We come along here, and in work we go to controllers, and we go to feathers, oh that's right, I made it a feather S2. Rename home, add a fruit. There we go. We go in here. Whoops. We open this up with Arc for a sec. Grab these, put them in here. Okay, so now we have all the bin files. Then what you do is you go over here. Okay, we have to put this in the thing. So that, let go. And then what you do is you go over here to the ABS web serial programming port. I can do this with the command line too, but we connect to the ESP, connect. Then we go choose a file. And we go to work, controllers. And we want the combined bin. And we open like so. And we say program. Maybe I should have done an erase then a program, but that's okay. So basically it's writing down a different set of firmware to the thing. We're going to be turning it into I think either Arduino or CircuitPython, probably CircuitPython. As we wait this out. So over here, I think in Visual Studio Code, I will close. Are we just in folder mode? No, we're in works. Oh yeah, we're definitely in folder mode. Close works folder. Okay, reset the new firmware. And we have the first boot. Okay, so now we have this. So we don't need this UF2. I'm going to bring it up to the current one. So we go back to the download again. And now we can scroll up. So we have 7.1 and 7.2 alpha. We're going to do 7.1. We're going to download the UF2 file. and we are going to put it in work, controllers, feather, TFT, save right here. Okay, go here on the Explorer, and we go work, controllers, feather, and we have this guy here. We copy it, we go to first boot, we paste it. So lots of blinky lights. Kind of hard to see. There you see it. In fact, the screen has stuff on it. It had TFT blah 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 on it. Okay. Now we have two CircuitPy directories. We'll mount this one. And there's our brand new CircuitPython on the TFT screen. Okay. So now we can go and to Studio Code here and open a folder. CircuitPython. Okay. Okay. And we are going to save this workspace out. And we'll call it Feather ESP32-S2 TFT. Let's save it. Now we need a Blink program. Not an Arduino Blink program. We need a Blink program for Python. So do I have a code.py with a chase? Nah, that's the one's too complicated. New Blink INO? No, we don't want that one. So we need to find a corresponding Blink program. So we find one. Feather ESP32 TFT, but not UF2. We want Circuit Python Blink. Yeah, I think I found a Blink program. Maybe not. It's a blog entry. We'll just borrow the ESP-S232 development board. That should have Feather ESP32. Yeah, we'll just borrow this one. If you want to looking, I'm just looking at websites. What we want here is the primary guide, and then we go CircuitPython Essentials, Blink, grab a Blink program, copy code, go to here, Control A, Control V, Control S, and there we go. One Blink program. Now, this is supposed to be the REPL. I think if you connect to it, oh, we need to choose a board in here. Feather. I think I'll just take the ESP32 with no PSRAM. Now we should be able to open this, and we can go that. Not sure how to send the REPL to the screen. It should do it. I have to play more with one of these things. But That's the S2, and that's, well, that's Feather. CircuitPython is a lot easier to deal with than the ESP-IDF. So let's switch over to the last board I was going to work on. This was a very big sidetrack. Close workspace and safely remove. I have, as I said, I have a second board of this, so we can change over later to a different one. Okay, so we're going to deal with now, I'm going to just move that over there. The S3, the one I had so much trouble getting working. Now, before you go gung-ho, 2 ports. This is a USB power slash and programming, but according to them, this is not 100% complete in the code yet. This is a UART port through USB. This is where we're going to plug in to program this. So, and as you can see, we have a big NeoPixel on it. So go back to here, and what we want to do is start a project. I'm just going to check my directory where I store these things. So this is definitely in the ESP IDF project directory. So I have this, and I have projects, and I have Blink. Okay, so this Blink definitely I know works on here. Okay, and it's specifically actually designed for this one. So when you're doing ESP-IDF, there's a bunch of demos from them, and you can run an F1 command in ESP-IDF and actually grab a demo. So we go here, and so if we say F1 show example projects. Okay, so you have all these examples in here that you can play with, whole pile of them, right? So we are going to do another Blink program. Okay, and I'm just going to rename the existing Blink here so that we don't get it in the way. We'll just call this blink.org. Okay. Okay, so what we're going to do here is copy project using the example Blink. And we are going to put this in. I need a terminal here. I just don't know where. Oh, right. We have to open a folder first. I keep forgetting about this. Open folder. And work ESP-IDF projects and say OK. Okay. So we are going to now do this, this, and then create a new project. And it's going to ask us where, and we're going to put it in here. We'll allow that. And I'm just going to say ignore that particular one. Okay, we are also going to go file, save workspace right away. In this case, we have ESP32-S3 Blink 2. And we'll save it. Okay. Now notice that this is the bash shell here. So I'm just going to close this because I don't really need that. I want their shell. Okay. Now VS Code has all this stuff. We have main. We have the Blink example. There it is. Now downstairs here, we just plugged it in, so we need to figure out, again, what we are on. T2I USB 0. This is wrong. So we create that, and we map it out. But, and this is the big but to all this. Settings JSON. This port thing here. Right? Now, I have to put that into the main this. See how this is all empty and the settings is nothing? So what I did here, and I'm just going to borrow the other blink, and we're going to load up this code workspace in Notepad. Copy. What we want this to show is this. Okay? So this sets those environment variables. So let us build. Okay, it's complaining. What was it again? This, I'm still not 100% on this. I got it working before. ESP32-S3, built-in USB JTAG. No, ESP programming. That one. Let's try that. Okay. Let's try building again. Oh, by default, it puts a pre-done build directory in there that doesn't work. Sometimes. And sometimes you have to hit the trash can to clean it out and then start over again. But there we go. Now, let's see if we can push our Blink program to it. Nope, it's complaining. And the complaint here is pretty obvious when you look at it. ACM1? No, it's not ACM1. Why in the frick does it think it's ACM1? It's USB 0. And this is the frustrating thing, is to get around this stupid problem. Because this should be the thing it's listening to. Okay, let's try this again. So somewhere it's picking this up all the time. It's just really annoying. And it's not this. There is no ACM1. If I plug it onto the USB side, it becomes ACM. If I plug it onto the UART side, it becomes USB. So I'm just going to just check this scan. It is USB 0. And this guy here, no, this is wrong. That's why we're having it. USB 0, Control S. We come back here again one more time for good luck. There we go. Okay. Now you'll find this in Visual Studio Code sometimes. The workspace JSON file overrides the settings JSON file. This one. Now, as I said, this Blink is more complicated than the one in Arduino or anything like that. Let's see if we take out and make this a 5. Control S. And we build it again. And we update it. Now there is a button here to build, update, and monitor at all the same time. Now, to me, the Blink hasn't changed. Okay? So I'm going to try a trash can clean. And build again. forcing all the code to be rebuilt. Now, I haven't completely mastered this environment. Okay. So there's like a build project here, and over here is a build select a target. So let's push this. And to me, the blink hasn't changed. It doesn't feel like it's changing. So that's the little problems I'm still working on here. So you can go and in here, if you go to their idea of a REPL, and there is one here, monitor. See? But you get the idea. It does now work, but we literally have two different environments for programming things. The earlier S3s can be done in PlatformIO. The Adafruit stuff, you have to set them up. I need to set one of these guys up with in ESP-IDF mode, in probably in Arduino mode, and probably in CircuitPython mode. And then, of course, these bleeding new edge ones like this. Right? Now let's stop the monitor. They have to be done in ESP-IDF. Let's stop the monitor. There we go. Sorry. Trash can the monitor. Thank you. Now, that's this one. And where's the little white box for that? Yoo-hoo, little white box. Where's that little container of white boxes? Okay, so that's this one. That proves that this works. So this was the ESP32-S3 Dev Kit C-N-N8R2 Rev 2. Okay, and we have a whole pile of others here. So this is the plane 8. So we should be able to plug this guy in. And as I said before on these things, the only way you can tell them apart is right on here. So this is the mini S3. Okay. Now, I don't believe in here there is any differences as far as the coding goes between this and this. So we're going to plug this in. Oh, that's a very bright LED. Wow. Yes. So this one here, what we want to do, first of all, just check what port it showed up on. USB 0 still good. We can stay with that. And I'm going to trash can this, and we're going to build it again. That is a very bright light. Okay, so we're done. Now we want to push it to this thing. So we are changing the blink from the factory. Whoops, I didn't mean to do that. Oh, if you do inadvertently recycle it and do it over again, let it complete. Breaking, it causes issues. But you can see it blinking. It's a lot dimmer. but it works. So this board is working. Okay. So that's the board. Whoops, I really meant to do that. Turn it around so I can actually have the labels up. So this is the N8, not the N8R2. So this is the N8R8 version of the board. Again, they're going to look almost identical, right? Except for the change on the product on it. So, and you can read R8 down here on the thing, right down there. So let's plug this one in. Big bright LED cycling through 4 colors. No, more than 4 colors. Okay. So maybe I don't have to. Let's try it. Just uploading. Yeah, we changed the blink. It is now different. And this one is working. So that's the 3 flavors of this board. So R8, R2, and R8. And then we have here, I think this is the mini N8, and we have the DevKit CO2, and I think these are just more of the other ones. Yes, 8. So this one. So this is the mini. Let's put it in. Very bright blinky. And we'll flash the device. And there we go. Flash is done. Click in, hit spacebar. Now it's just one color and it's flashing a lot slower. Ta-da. Put that on there like so. And the last one is a teeny weeny little one. Now this one only has one connector on it. It's like the older school ones. And this is a ESP32-C3 room 02. And it has one light on. Ooh, pretty big. Yeah, pretty bright. Okay, so let us... Fatal error. Okay, so it's showing up as... Well, it's USB 2.0, but it doesn't like the code. So let's see, what was it complaining about? Oh, this is a C3. So we need to change this. C3 ESP programming. There we go. Let us build again. Okay, let's trash can it. And build again. There we go. I have to build all the files differently. Okay, so we built it. Now let's fire it up there. No. Okay, so this is a sign that one of these JSON files is wrong. So this one says here C3, and this one here still says S3. So Control S, come back to here, and fix it. Nope. Okay. Will you get out of there? So I still have the wrong chip. Oh, Control S. Let's try again. Nope, we're still doing it. So we're still thinking it's the wrong chipset. ESP32C3. ESP32-C3 programming. Yes, ESP programming. Okay, JSON says it's C3. ESPO. C3. It could be a possibility that this is not in there. So let me just go grab Control C. Come over here. Semicolon. Control V. Sorry, no, not semi. I mean a comma. We need the damn other square bracket on there. Okay. End square. Control S. Let us try that again. Trash can it all. Rebuild it. And I did say it found a C3. Okay, let's try pushing to this again. There we go. What did I say? Stupid workspace files is overriding the settings file. And there you go. Blink, blink, blink. Ta-da. So that one works too. Although I think they got cheap. I rather have the little foam things in here actually. But that does that one. So we can now successfully program basically all the ESP32s. Right? No matter which one it is. But it took a bit of work to get the ESP-IDF to work correctly. As I said, most of the problems stem from the build process getting confused which chip it is, or the JSON settings and the workspace settings JSON file fighting over who's actually defining everything. Ignore this area. Apparently this only becomes relative when you actually compile. It's stupid. You get an orange error on it, but it's not 100% correct because the environment variable isn't really set yet. If you do this sort of command, grep IDF, see, it is correct. IDF path, right? That's what that thing's complaining about. Just ignore it. Not important. Right? Now, of course, the code thing here, all this is classical Visual Studio Code. I can't figure out my IntelliSense properly. Even though I've told it where everything is, right? I wouldn't worry about it. I'm going to look into seeing how to fix that. That could be a case of I have to add path variables and saying look over here for the things, or look over there for the things. Same thing I had in CircuitPython. I had to figure out how to tell extra paths to be parsed and looking for things. So I might have to put it in here. So right now this is just the path. What I might have to put in here is path is really IDF path. You know, this. Or this. Right? For example, I don't know if this would fix it. For example, you go like this, and you go comma, and you go path, colon, and then you go like this, and you go Control V, whoops, Control Z, Z, and this guy right here, you go, whoops, if I can properly do this, copy, and Control V, duplicate key. It could be path has to have I don't know, a colon, Control V, sub ID. That could be it. Something like that, right? Or it has to be semicolon. You can try and see if this fixes things. Obviously, I did something really weird to this. It doesn't like it. Could be spaces we have to have. Semicolons. Obviously, done something. The tree kind of disappeared over here. I wonder if it's like there we go. Blink is back. But if the code in main, wow, that's interesting. Did we actually fix it? No, we didn't. So there's still, now there's 11 errors in it. It doesn't like the path. I wonder what the heck that is. Let me look at Visual Studio Code and look that up. Visual Studio Code, work space path variable. Variables reference. Let's see what it has to say. This is what I'm looking at here. Workspace folder, file, exact path, file, no, what we want is control, what was it, Control F. We're actually what we're looking for. Yeah, it doesn't like something in here. We're trying to find path. Oh, interesting. Okay. Well, this is very unhelpful here. Let's see if we can change the search. Let's see. Workspace, multiple paths. Well, that defines the root. Yeah, I'm pretty sure it doesn't like this part here. I'll have to look that up and figure out how to tune that. That's that same crap that the CircuitPython was having when you couldn't include modules. So I just need to figure out how to do that. But in the meantime, file, close workspace. There we go. And I will call this vid at this point. If you want me to do more ESP32 stuff, I can. So, or I can do more pure Arduino. I'm going to see if I can actually, well, these two here, this one and this one, both do Arduino out of the box. So, but they can also do ESP-IDF. You look at that Blink program, and it's way more complicated for doing the Blink. So I'm not sure what those guys were getting at when they wrote that. But I haven't really tackled the nitty-gritty stuff on any of this, so we'll find out. So have a nice afternoon, a nice evening, nice morning. Depends where you are in the world. Bye.